PDF files. The answer is out there.
The Microsoft Fabric Certification Podcast with Kevin and Frank.
Episode 4. The Memory Mutation.
I have a question. Your organization uses Microsoft Fabric to manage data engineering tasks. The current setup includes a starter pool for Apache Spark jobs, but the team notices that some jobs require more compute resources than the starter pool can provide. You need to optimize the workspace configuration to efficiently handle larger Spark jobs without significantly increasing session start times. Each correct answer presents part of the solution. Which 2 actions should you take? Select all answers that apply. A. Create a custom Spark pool with autoscaling. B. Disable the starter pool. C. Enable dynamic allocation of executors. D. Increase executor memory in the starter pool. E. Increase the number of partitions in the Spark job.
Hey, Kevin, how are you doing?
Good, thanks, Frank. How about yourself?
Yeah, fantastic. Thank you very much. So, well, we have a new question, obviously, right? And this time it is about Spark. So, probably for all of our listeners who might not know so much about data science, data engineering, big data, stuff like this, or might be more on the SQL Server side of things, could you please explain what exactly is Spark? So what is doing?
I like how you're always asking me questions, which can be at least a full session in themselves these days. So, for the benefit of everybody at home, our compute is what is effectively used, Frank, to manipulate data that you've got stored. Now, in the case of Microsoft Fabric, for example, you use Spark Compute to manipulate what's in lakehouses. There has been ways that you can work with Spark to manipulate large amounts of data and other platforms in the past as well, with data stored elsewhere. So, for example, when you're working with either Azure Databricks or Spark Compute. Now, the compute itself is actually, you can think of them as virtual machines that are hidden behind the scenes that you work with. You tend to work with either a standalone virtual machine or you work with a collection of these machines, which is known as a Spark cluster. And the idea is when you're working with a Spark cluster, you run code to do something, and then behind the scenes, that code is split among these many Spark clusters and is used to return various things like data or the outcome of your code back to you.
Okay, so just for me to understand, right? So what this is doing behind the scenes is it is just parallelizing what I want to do, right? So so not only everything will be just done on one of these virtual computers, but the task is split and then it will be executed in parallel,
Exactly.
right?
The work will be distributed amongst the machines behind us in your Spark cluster. So for those of you, if you're using it to manipulate data, those of you who have a SQL Server background can basically think of a Spark cluster as in-memory LLTPs distributed amongst multiple machines. Obviously, there's a lot more complicated than that, but that's a good way to explain it to those with a SQL Server background.
That's pretty cool. And thinking about Spark, so what do I have to think about? How can you said something about programs that are running on this? So how do I write these programs? So what language do I need C# for this?
Typically, you will use what's known as notebooks to do this, and these are a set format usually in your servers of choice. So you have notebooks available in Microsoft Fabric, for example, and you have done in the past with other services as well. And there's a variety of things that you can do which are common in all these types of notebooks. Some of the languages you can work with. So, for example, you can work with a variation of Python called PySpark, which is very popular with people that work with Spark, basically. You have Spark SQL as well, which is a form of ANSI SQL you can work with. Tends to come with additional commands. Now, if you're working with, I'm not going to go too deep here into the data that you stored, but if you're manipulating, for example, delta tables that are stored through these notebooks. You can use things like time travel with Spark SQL. That's as far and deep as I will go into that kind of explanation for everybody, though, because we will end up going off topic a bit. So the question is how to improve the performance of these types of Spark clusters effectively for you. So these Spark jobs, which are essentially predefined things, tasks that you want to be performed in your Spark cluster.
Maybe one thing I would like to add to this question as well, because this is in our series, this is the very first question that we got with this type of question. So in this case, it's not only one answer which is correct, but there are probably multiple answers which are correct. And what we have to do now is we have to find out which of these answers are correct. And what makes it a little bit more difficult than the real test is that here is select all the answers that apply. Usually in the real test is select 2, select 3, whatever, how many answers are correct, right? So we have to think about not only the correct answers, but also about the number of correct answers. So shall we think about probably the first one, create a custom Spark pool with autoscaling. So Kevin, can you talk a little bit about this? So what is this doing? So a Spark pool with autoscaling. So what do I have to think about this?
Yeah, this basically allows you to create a predefined collection of your Spark virtual machines, I will say, your Spark nodes essentially together. Yeah. So you can customize, you can say, for example, how many the compute that they're backed by default, and you can also enable auto scaling as well. So as the demand or the demand for compute increases on that particular cluster, it would actually auto scale up and down over time to cater for your needs. So for this particular scenario, where we need it to be done efficiently without increasing the session start times, etc., this is probably a good option for us to do.
Okay, so we will keep A in mind as one of the correct answers, right? Okay, so let's move on. Disable the starter pool. How do you feel about this one, Kevin? Please tell us.
It's an interesting answer for sure. Yeah, so if you just go to disable the starter pool without doing anything else, then yeah, you're probably going to be in a little bit of trouble, to be honest with you, Frank. So
why is that?
Well, you'd have no compute to start with.
Okay, got this. Okay, so you think this is not a good answer?
Yeah.
Okay, so I think we will just get rid of B. So let's move on and let's think about C. C is enable dynamic allocation of executors. So what about this?
Yeah, to be honest with you, this is a good thing to do if you're working with custom Spark clusters, to be honest with you, because it helps with the amount of demand that you're getting on your Spark clusters that you've created. So based on the demands again, so it's in line with the auto scaling I was mentioning earlier. This is kind of an impact for it as well, so it's pretty good.
Okay, so at the moment what I get from this is we have A and C as the correct answer. So let's move on and let's see what D is. D is increase executor memory in the starter pool. Okay, how about this? More memory is always better, right? So if you have more memory in a SQL server, it's always better. You cannot have enough memory, right, Kevin?
Yes and no. I mean, in this particular case, it's the starter pool. I mean, if you've got no auto scaling, how is it going to take into effect, Frank?
I don't know. I ask you.
Well, not very well is the answer.
Because the thing here is that this is about compute, right? And if you have a bottleneck in compute, you can put in as many memory as you want. It will not solve your bottleneck in compute, because the only thing what you are providing then is just memory, right? And not additional compute.
But it's executor memory as well. It's not adding additional memory as such. So yeah.
Yeah, exactly. This is a very, very important point as well. Yes. Okay, so let's move on and let's have a look at E. Increase the number of partitions in the Spark job. So let's talk about partitions in the Spark job. So what will this do?
What will it do, or what will it not do? Because it won't address the issue that we've got at this moment in time, that's for sure.
Okay, so what's left now is answer E is about increasing the number of partitions in the Spark job. So what will this do?
Well, it's not so much a case of what I will do, is what I won't do, because the question is actually about the Spark jobs themselves. So this won't actually have an impact on this particular scenario, to be honest with you.
Okay.
So
So I think if we summarize up everything that we were talking about until now, then probably answer A and answer C are the correct answers, right?
yeah,
So, and we solved the mystery about how many answers are right. In this case, these are 2, right? But for everyone who wants to know more about Spark jobs and who wants to know more about Spark, what we will do is we'll put some links in the show notes, right? Okay, so now this mystery is solved. Do you have to add anything as well, Kevin?
yeah, I do actually, Frank. Just make sure, folks, when you're looking to study for the exam, you actually go through the Lakehouse material and get to speed with what all these various settings relating to managing a Spark cluster actually do, especially in the context of working with workspace settings and environments. I just want to add that all there for everybody, just so you're all confident about these Spark cluster related topics before you go to sit the exam.
Yes, that is true. Okay, with that said, I will say, well, the Spark cluster is out there somewhere, right? And so have a good time, take care, and bye for now.
Thanks, folks. Bye.
Bye-bye.